Here is the assembly emulator that we looked at in class before we closed down for coronavirus. This is the example Hello World that we are just going to run through real quick. We did this in class together, but it's been a while. A lot has happened. We're just going to walk through the steps together so you can have a refresh of how this works. So I really love this emulator. I don't actually know the name of the person who made it. It might be in the source document somewhere, but it's really great. We've already done a little bit of work getting comfortable with how steps work in assembly, and this emulator is going to let us try it out for ourselves. So the first thing I like to do is go down here and change some of the options at the bottom. I like to show all of the color coding because I find it really helpful. And I like to change the view from hexadecimal to decimal because while hexadecimal is very, very useful, my mind does not by default work that way. So I like to look at it in decimal. All right, so this is the Hello World program. All it's going to do is print out Hello World in the output section up here. So we're going to watch how that happens. You can see that the gray section down here is the same gray as the output section. That's because in this part of RAM, whatever you put in this section of RAM is what our output is going to be. All of these start out empty. Our registers start out empty, and our 0 flag, our carry flag, and true false. So we are going to step through this program, see what happens. So our very first step, you can see that a whole bunch of stuff just showed up in RAM over here, right? And what that is show that one more time. So we got lots and lots of zeros and poof, stuff. So the instruction that just happened is here, setting up this variable with the hello world as what's being saved. And you can see it right here. This is an HELLOWORLD exclamation point, right? There's a space in there somewhere too. So that may not look like the hello world to you. So if it doesn't, that's okay. What we're missing is an ASCII table to help us convert between one and the other. So let's take a look here. So capital letter H, where did it go? Right here. You can see that that is the number 72 on this ASCII table in decimal. If we had stayed in hex, it would be the number 48. We switched to decimal, 72 is capital letter H. We can go look back and see this number 72. That's our capital letter H. If you went through all of these numbers on that ASCII table, you would come up with hello world, but we're just going to watch it happen. All right, so next up, this is the line. The highlighted line is what's going to execute next. So we are going to need a way to find out where our variable is. So we're going to use this command to let that happen. Hello was the name of our variable, and so we're going to figure out where it starts and save that into register C right here. Let's watch that happen. All right, so that 72 is the capital letter H, and it is in spot 2, right? Because in computers, we start at 0. So 0, 1, 2. So C is the number 2, pointing to the start of our variable. The color coding really comes in handy here. All right, next up, we're going to move the number 232 into register D. Why 232? That's crazy. Let's watch. Aha! So our color coding, 232, we can see that that is the beginning of our output section. So this is how we're going to be able to get our program to give us output. Whatever we send down there will show up in our output line in just a minute. Okay, so that's why 232. All right, next, the blue line says we're going to call our print function. And what that means is that we're going to jump down to this function that we have named print. This is what functions look like in this assembly emulator. So it's going to help jump down there. Push and later pop, useful but not critically important to the examples that you will be doing. So I'm going to breeze on by those for now. Next up, we're going to put 0 in B. Now, technically, there's already a 0 there, but this is just good form because we're going to want to use it later. We wouldn't want something else to accidentally be there if we'd run another program previously. All right, so B is definitely a 0 now. We're good. Okay, we're now getting into the actual loop section of our program. This is the part that's going to actually do the printout. So let's see what that looks like. So we're going to get a character from our variable. So far all we've done is put our variable in and kind of set up our framework to get us started. Now we're going to go get whatever that first piece is, in this case the number 72, and we are going to save it into register A. So we're not going to get the number 2, right? We're going to get what's in space number 2. So this is where this is pointing to. So you can see on the previous line, we looked at what C was pointing at, the number 72, and we moved that up into the A register. Good. Our next line, we're going to take what's in the A register, so actually in the A register, the number 72, and we're going to put it where D is pointing. So we're not going to save it here, we're going to put it way down here in space 232. Okay, so now that 72 was put where D is pointing, see it down here, 72. And because this is part of our output section, you can see that it showed up on our output line as a capital letter H. INC is increment or increase, right? So we're looking at actual C right now. So C is the number 2. Inc C is going to increase that by 1. So now we have the number 3. Why would we do that? Well, we want to look at the next character in our variable. So we have gone from looking at the first spot to looking at the next spot. We just increase by 1. Increase D, we're going to do the same thing. This 232 is going to become a 233. Why would we do that? Well, down here, we need to go from this first output spot to this next output spot. If we didn't have this increase D line, we would overwrite the first spot over and over again. Maybe that's what you want your program to do, in which case you can get rid of this line. Okay, so now our D is getting ready. It is highlighting on the next spot to become 233. So we will be ready to write our next letter next to the H instead of over top of it. All right, CMP is compare. We're going to compare what C is pointing at. That's what those brackets mean. What C is pointing at is 101. And what's in B. Now you might remember that we made sure B was 0. So we're currently going to compare 101 to 0. Why would we do that? Well, way back up here at our starting spot, when we set up our variable, we set up 0 as the string terminator. So that means a 0 is letting us know when we're done, when we have reached the end of our variable. And you can see down here in RAM, HELLOWORLD exclamation point 0. That 0 is going to tell us when we have finished. So we are checking right now, is 101 the same as 0? It is not. So I want you to keep an eye on these over here. Okay. So now we need to jump if we are not the same. Okay, so we are not the same. So we're going to go back up and start the loop over again. See here where it says dot loop. So we're going to go to the top of the loop and go on to the next character and keep going. The 0 flag right here is showing us that we are not 0. If we had compared our 101 and 0 and they were the same, we would have a different result, and we'll see that in a few minutes. Okay, so we checked if 101 and 0 were the same. They were not. We're going back up to the start of our loop and go to the next spot. So this is going to be very repetitive. You're going to watch what happens. We're going to get whatever C is pointing at and put it up in A. Now we're going to put A down in D. There's our E in the output line. We're going to increase C, increase D, compare what C is pointing at, in this case 108 to 0, see if we're done. Are we done? Nope, gonna keep going. I'm gonna click this button many times. Hold on. Okay, we're almost there. So we're gonna increase C, increase D. Now we have done our entire variable to the output section. C is the number 14. It is now pointing at 0, which means we are at the end of our variable. That's our string terminator. We're now going to compare what C is pointing to, 0, with what B is, 0. Ha! See, the 0 up here has changed to true. That's because they're the same thing. So this command is no longer going to execute. When this was not 0, we started back up at the top of our loop. Now it is 0, so we're just going to keep going. There's the pops. RET means return. So all of this took place inside our print function. Here's where we called our print function, so that's where we're going to go back to. Next up is halt. Ends the program. That's it. We're done. We printed hello world. It is not a revolutionary program, but look how many steps that took, right? When we did this in Python previously, the only thing we had to do was type print hello world and we were done. This is a little more involved. So I need you guys to take some time and make sure that this makes sense. You can try doing things like either commenting out. So in this case, a semicolon is a comment. We can comment out this increase D and watch what happens. Remember, we said increase D was how we moved from one output spot to the next. So what's going to happen now? There's our H, O, E, L, L, O. So they are all still printing out, but they're overwriting that single spot instead of lining up the characters in a row. Okay, so you should try changing a few things in here to make sure you understand how this program works. When you're ready, you can go on and try the program assignment that I gave you that's in Canvas. One thing that you're going to find really helpful, right up here at the top, it says instruction set. Click on that. Here is the list of all the things you can do. This is your API. So if you scroll down, it talks about constraints, and then it goes into commands that you can use and how. For example, MOV, copy a value. We've used that a number of times, right? Here, 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 all sorts of places. You can move between registers. You can move an address to a register, a constant to a register to an address, or a constant to an address. It's the only combinations that exist. You may have wondered, why did we copy this up here and then down there? Why didn't we just take what C was pointing at and put it straight to the output line? Well, you can see that that's actually not an option. You can't go address to address, which is what you would have needed to pull that off. All right, so there's a bunch of other stuff in here, math operations, the increases and decreases, multiplication and division, logical arguments, those might come in handy, shifts, compares, and then all the different types of jumps that you can use. These all look at those carry or 0 flags. Those are over here. Carry is the C, 0 is the Z. Those are what you want to keep an eye on for what triggers and doesn't trigger those loops. Call functions, that's if you want to make more functions, you could make this now a function named end just by doing that. All of this stuff that you could possibly need should be in there. However, some of these can be a little confusing. Think back to our practice problems. Think back to the Hello World example. I'll try and add another example here, hopefully by the end of this week or maybe the beginning of next week. If you get stuck, let me know. You can email me. You can put questions in our class discussion post. You can ask each other. We'll have some time to work on this, but this is where we are. Don't forget to do things if like add a header, and as you change the program to do something new, add comments that explain how your program works now. All right, I think that should be enough to get everybody started. And let me know if you have questions. Okay, thanks guys.